Welcome to this explainer. I am absolutely thrilled to share today's topic with you because it literally challenges the very foundation of how we understand energy. We're looking at a genuinely groundbreaking paper by physicist and mathematician Dr. Ahmad Rihan titled Reinterpreting Thermodynamic Laws Through Transverse Magnetic Spiral Dynamics. What this paper does is, well, it's nothing short of extraordinary. It fundamentally redefines our understanding of heat. We're not just talking about random particle motion anymore. We're looking at heat as an incredibly organized, dynamic electromagnetic phenomenon. If you've ever wondered how the universe actually distributes energy at the absolute most microscopic level, you are going to love this framework.
Okay, let's dive into this by starting with a question that, at first glance, seems totally unrelated to theoretical physics, but it's actually deeply connected. Why are planets round? And what does that have to do with heat? We see spheres everywhere in nature, right? From massive burning stars all the way down to the fruits growing on trees. Now, we usually credit gravity or biology for that, but what if the answer actually lies in a completely new definition of thermodynamics? The secret to this everyday mystery is actually hidden in the way heat travels. And to understand it, we need to rethink pretty much everything we know about thermal energy.
To really appreciate this massive paradigm shift, we need to contrast the old with the new. Traditionally, the classical view, using standard statistical mechanics, models heat as essentially randomized particle motion. Atoms vibrating and just chaotically bumping into each other. And sure, it's a powerful model, but it leaves a massive gap when you try to unite thermodynamics with electromagnetic field theory. But Dr. Rihan's RAM view completely flips this on its head. In this novel electrodynamic framework, heat isn't just chaotic bumping, it's actually the macroscopic manifestation of transverse magnetic spiral dissipation. To put it simply, heat is the byproduct of incredibly organized, spiraling magnetic waves happening right at the atomic level.
Section 1. The Microscopic Engine. Introducing the RAM atomic model. Now, what's really interesting about this concept is how we can visualize it. To grasp how these magnetic spirals create what we physically feel as heat, we have to zoom all the way down to the smallest possible scale. The Rihan, or RAM, atomic model proposes that right inside the atom, there is a central pyramidal body. And this body isn't just vibrating back and forth in a boring straight line. No, it's executing what Dr. Rihan calls chiral helical jumps. Imagine a microscopic pyramid springing upward and twisting, then dropping back down and twisting again. And as it does this continuous dance, it generates spiral magnetic waves that literally reinforce themselves.
Let's actually break down the mechanics of this motion step by step. First off, this pyramidal body follows a helical trajectory. Think of it kind of like moving up and down a tiny spiral staircase. When it ascends, it revolves to the left. When it descends, it reverses and revolves in the exact opposing direction. Because these specific movements carry a charge, this up and twisting, down and twisting motion creates alternating, highly effective microscopic electrical currents. It's this continuous, rhythmic, spiraling engine running non-stop inside the atom.
Section 2. The spiral feedback loop.
Let's move along and see how this builds into a positive feedback cascade. Because a single atom doing a dance doesn't give us a hot cup of coffee. Step 1. Our single atom performs its helical jump. Step 2. Because it's a moving charge, it radiates a spiral magnetic wave outward. Step 3. This wave travels and physically hits neighboring atoms. And if those neighbors are parallel, the wave actually exerts a magnetic torque on them. It literally pushes them. Which leads to Step 4. Resonance. The neighboring atoms are forced to jump with greater amplitude and at a higher frequency. It's a complete cascade effect. One twisting atom forces its neighbors to twist harder and faster, and then they in turn send out even stronger waves.
And this brings us to a really fantastic visual from Dr. Rihan's research. The study notes, and I quote, "The atom puffs greater quantities of organized helical kinetic energy into the surrounding medium per cycle." I absolutely love that dynamic verb, puffs. As that feedback loop we just talked about accelerates, the atom literally puffs out energy. Now, it starts as highly organized, spiraling kinetic energy. But as it interacts with the surrounding medium, things like scattering and damping turn this beautifully organized magnetic motion into the randomized kinetic energy that eventually registers on our thermometers as a rising temperature.
Section 3. Rewriting thermodynamic laws.
So, if heat is actually this microscopic magnetic spiral puffing energy around, then the foundational rules of classical physics definitely need an update, starting with the zeroth law, which is all about thermal equilibrium. In the RAM model, equilibrium isn't just particles bumping equally, it actually happens when those transverse spiral waves are disseminating at perfectly balanced rates across a system. Moving to the first law, conservation of energy. Dr. Rihan extends the classic Poynting theorem, which is what we use to calculate energy transfer in electromagnetic fields, so that internal energy now explicitly accounts for these spirally dissipated heat waves. Then there's the second law, entropy. Why does disorder always increase? Because that feedback amplification we covered actively accelerates randomization. Stronger parallel jumps just create broader, messier wave dissemination. Finally, the third law. Absolute zero is unachievable because as you get colder, you exponentially suppress these helical oscillations. Sure, but residual quantum motion means you can never totally stop the spiral wave feedback. There's always a tiny flutter.
So the crucial point is how this behaves in three-dimensional space. In spherically symmetric bodies, these spiral waves propagate radially, meaning they move outward from the center. Because of the geometry of a sphere, this radial propagation ensures that every single horizontal contour, or layer, experiences the exact same identical reinforcement of these atomic jumps. The waves spread out perfectly evenly, which results in a perfectly uniform horizontal temperature all the way across that layer.
Section 4. Spirals in the universe, from atoms to planets.
And this brilliantly illustrates why this theory matters in the real world. And it finally answers that everyday mystery from the beginning of our explainer. Think about induction cookers in your kitchen. They heat up incredibly fast by exploiting this exact mechanism, triggering high-frequency spiral eddy cascades that rapidly puff energy as heat. Peltier cooling? That works by using electrical currents to precisely modulate these atomic jumps. Combustion is essentially just an initial activation that sets off a massive, cascading avalanche of these helical puffs. And this brings us right back to planets, stars, and even fruits. Why are they round? Because nature inherently prefers spherical shapes to optimize this exact isotropic spiral wave heat dissemination. A sphere is literally the most efficient geometry possible to ensure uniform thermalization at every single radial shell.
What makes Dr. Rihan's paper so incredibly compelling is its scalability. We're talking about drawing a direct parallel between microscopic ram waves, that atomic helical mechanism we just walked through, and macroscopic eddy currents, which are governed by Lenz's law, the principle where induced currents oppose the change that created them. The RAM model argues that these two things are fundamentally the exact same phenomenon, just operating at vastly different scales. Those tiny atomic-scale magnetic swirls are the exact microscopic machinery that builds the large-scale eddy currents opposing the driving flux. It's all connected.
Which brings us to a final, really provocative thought. The research states, quote, "This innovative synthesis not only recovers classical results, but opens new avenues for energy engineering and materials design. By reimagining heat, not as some random, chaotic bumping of particles, but as a deeply structured, self-amplifying magnetic spiral, we aren't just rewriting physics textbooks. We're opening the door to revolutionary new magnetothermal devices, hyper-efficient energy grids, and advanced materials tuned specifically to helical resonances. If heat is actually a magnetic wave, how will we choose to surf it next?" Thank you so much for joining me for this explainer. I really hope this sparked your curiosity to go out and learn more.